Hello, everybody, and thank you for joining us today for Vertica Unify 2021. Today's breakout session is entitled Tuning Vertica for Performance at Scale. I'm Jeff Healy. I lead Vertica Marketing, and I'll be your host for this webinar. Joining me are Rakesh Bankula, Customer Success Manager, and Hibiki Sarazawa, Customer Success Engineer from Vertica. Before we begin, I encourage you to submit questions during the virtual session. You don't have to wait. Just enter your question in the Q&A box on the right-hand side of the screen. There will be a Q&A session at the end of the presentation. We'll answer as many questions as possible during that time. Any questions we don't address, we'll do our best to answer offline. Alternatively, visit the Virtual Developer Lounge to ask additional questions and continue the conversation with our engineers and product experts after the session. And yes, this virtual session is being recorded, and will be available to view the session and others on demand this week. We'll send you a notification as soon as it's ready. Please stick around to get the code at the end of the presentation to gain points, participate in our Analyze to Win competition and win prizes. Now let's get started. Over to you, Rakesh.
Thank you, Jeff. Hello, everyone. My name is Rakesh Bankula. Along with me, we have Hibiki Serizawa. We both are going to present this session on tuning Vertica for performance at scale. Here is the agenda of the session. I'm going to cover the initial part on how to find the resource contentions and tune resources. Next, we discuss the query plan analysis and required modifications for better performance. Then we discuss depot pinning policies in Eon. Hibiki will cover few customer use cases and solutions applied to improve the performance. Resource contentions and tuning. Resource contentions can be system related due to slower disk I/O, network throughput, or CPU related. Or the contention can be Vertica related due to resource pools not properly tuned to meet the workload requirements, or it can be a lock related or a catalog related contentions. Vertica provides tools VCPUPer, VIOPer, VNetPerf to check the performance and throughput of system resources. It is recommended to run these tools on all nodes on initial cluster setup and every time you add nodes or subclusters to an existing cluster. VCPUPer tool helps testing CPU performance. It gives the info on expected runtime on different CPU types and the runtime on the test machine. The test result should be equal to or better than the expected runtime for a given processor type. It also shows the low load and high load times. If the low load time is much larger than the high load time, it indicates CPU scaling is enabled. It is recommended to disable CPU scaling. Let the CPUs to process at highest possible frequency. VIOPerf tool helps testing I/O throughput. Make sure to run this test on catalog and data directories. Vertica recommends a 40 MB per second per core or more I/O throughput. For better I/O throughput, set the I/O scheduler to deadline or noob. Default is CFQ. On Red Hat and CentOS, deadline noob I/O schedulers perform similar and better than CFQ. On Ubuntu OS, it was observed that noob gives better I/O throughput. VNetPerf tool for testing network latency and throughput for both TCP and UDP protocols. This utility can be used to detect if throughput and latency is low for all nodes or a particular set of hosts, or is there any bottleneck between one or more hosts or within a subnet. 10 Gbps or more network bandwidth is common configurations at most of our customers. You can run VCPUPer, VIO or VNet on an idle cluster and save the test results as baseline numbers to compare when database performs slower. While DB performing slower, you can use any Linux tools like top, SAR, netstat, etc. to measure the present resource usage and compare it with the baseline numbers. Vertica also provides data collected tables which stores info on different resource usages at different intervals of time. Some of the DC tables are shown here. Query consumptions is a view written using these DC tables which provides the info on resource usages per query. If any of these system resources on any node are saturating, then mostly it is the cause for the database slowness. If the DB performs slower, even before saturation of any of these system resources, particularly if your database was performing fine all these days, but suddenly started slow down and continued performing slower without any changes in the query workload or any software upgrade, indicates some system resources issue. Examples like disk controller performance may be degraded, or network interface card dropping packets, or network switch having issues. Out of different performance issues reported by customers, almost about 20 to 30% of the cases turns out to be hardware related. Hardware related issues are the main cause for the slowness. It is important to review the system logs, D-messages, etc. to identify system side issues and correct it. We also see OS-related contentions, particularly in thread allocations or memory allocations, can also be the cause for the overall slowness of the DB. So for these to identify if the OS-related contentions are causing any problems, the perf tool, which is a Linux tool, we use it to identify if there is any contentions from the system side. So some of the main causes for heavy resource usage are long running a big or analytic type of queries, which may be having multiple joins, aggregations, etc. And also the second main cause is high query concurrency. So we will discuss each of these on how to control it by using a resource pool tuning. Vertica Resource Manager allocates resources to queries based on the settings on resource pool. Some of the important resource pool parameters are given here. Any query on a given resource pool starts execution with similar size of memory allocated as per query budget, which is calculated using the memory size and plan concurrency settings on the pool. Also starts with number of execution threads as per the execution parallelism settings. So it is good practice to run queries which requires similar size of resources on the same pool. If there is a requirement to run the mixed workload, including both simple and complex type of queries, where a simple query may run fine by using just about 1 GB of memory, but say a complex query which requires more than 100 GBs of memory, then single resource pool is not sufficient for this kind of workload, because a big query may hold most of the memory available on the pool and execute longer, impacting other short queries on that pool. The solution for this kind of workload is cascading resource pools. The parameter shown here, cascade2, can be used to move a long-running query to secondary pool based on the runtime cap settings. We can also restrict the query to use subset of CPU cores by setting CPU affinity as well as CPU mode, affinity mode. For a short query, high concurrency workload, short query does not need much resources. So consider adjusting the query budget by tuning memory and plan concurrency to about 1 GB. Similarly, set execution parallelism to 1 or 2. For dashboard kind of workload, where there is a shorter SLA, say about 10 or 20 seconds, then there is no point in letting query in execution much longer than the required SLA, if users are not going to wait for the results that long. Consider cancelling long-running queries based on SLA thresholds using runtime cap settings. Similarly, queue timeout can be set not to keep query waiting longer for the resources. Allowing to run large number of concurrent queries could lead to resource contention or saturation and result in a degraded performance. You can use max concurrency settings to limit number of queries to execute concurrently. We could get better query throughput by running less concurrency without any resource contentions compared to high concurrency with resource contentions. To see any further scope to improve the query performance by tuning resource pools, we would recommend to experiment by modifying query budget by adjusting the memory and plan concurrencies on the pool. Majority of the queries perform well with a budget of about 1 to 8 GB. Some large queries with multiple joins may require more than 8 GB of budget. Similarly, execution parallelism, which controls the number of threads, most of the queries perform well with about 4 to 16 threads per operator. If there is any query which is consuming most of the memory and impacting your query to wait for resources, can be controlled by setting max query memory size. Here are some important system tables for monitoring and troubleshooting purpose. If there are sufficient resources to meet the requirements of query workload and pools are properly tuned, then at any given time, resource queues should be empty. That is, no query waiting for resource allocations longer. Resource pool status info helps to live troubleshoot to find on a given pool how many queries are in execution, query budget, memory in use, etc. This live info analysis helps to further tune the pools based on your workload requirements. DC resource acquisitions gives historical info on how much memory a given query acquired. Query plan analysis and modifications. For a query to perform well, in addition to the resource allocations and tuning, it requires a good query plan. Vertica uses cost-based query optimizer. It relies on data statistics to produce query plans. If statistics are incomplete or out of date, the optimizer is liable to come up with suboptimal plan. In the query plan, we can also find projections used, row count on the given path ID, any data redistributions during the query executions. To check if a query plan utilized full statistics or not, you can run explain on the query. Closely look on the storage access path line for no statistics or predicate out of range info. If it present means that table is not having up-to-date statistics. So consider to update statistics for better query plans. Query event system table also shows statistics related events and provides suggestions on which table to update statistics. So frequently monitor this table and update statistics on all reported tables. So as statistics plays important role in better query plan generation, so here are some best practices on when to collect the statistics. So collect the statistics after you initially create a table and load the data to it. And then on, collect statistics if there is 50% or more data change in a given table. Query events table, as I explained in the previous slide, also provides you suggestions on tables where statistics are not up to date. So make sure to update the stats on those tables. Also, Vertica provides a partition-based statistics collection. Say, for example, if you have a daily partition table and you would like to create, you are storing about 2 years worth of data, and if you are loading into the present day and your plan is to run the queries on the present day data or maybe previous day's data, so make sure to run the statistics only on those partitions where you plan to run query. instead of running the statistics update on the entire table. So projection design plays an important role in query performance. Segmentation class of the projection design used in distributing data to all nodes in the cluster. Ideally, data should be distributed evenly across all the nodes. But if there is any data skew, which could cause performance degradation as the node with more data takes longer to complete the execution. To check if there is any data skew, one can query storage containers or projection storage system tables, aggregate total row count based on the projection and the node name, compare the results. Slight difference in row count between the nodes is okay, but there should not be a big difference like 20 or 30% of the data size difference between the node to node. To prevent data skew issue, design projection segmentation using 4 or 5 high cardinality columns. Or you can also use database designers for better projection design. Vertica Query Optimizer automatically chooses a set of operations to compute the results. The choice of operation can significantly affect how many resources are needed to compute the query results. And also, is there any data redistribution during the runtime of the query? Okay. There are two methods for aggregating data: group by hash and group by pipeline. Group by pipeline executes faster and requires less memory compared to group by hash, but it requires data to be pre-sorted for the columns used in the group by class. For query plan to pick group by pipeline, order by class of the projection design should match with the columns used in the group by class of the query. Similar to this group by operation, there are two methods for join operation, which is hash join and merge join. Merge join executes faster and requires less memory compared to hash join, but merge join requires data on the join columns are pre-sorted. For a query to perform faster, there should be minimal data redistribution during the query runtime, because network send and receive are the slower operations. More the data query execution needs to redistribute, slower the query performance. Explain plan shows if there is any data redistributions. As shown here on the join path ID, you may notice outer is resegmenting, or it can be both inner and outer are resegmenting or broadcasting. You can correct this by making sure statistics are up to date. In a rare case, if it still not helps, we may have to use query hints to manually force. Hibiki will cover a use case on query hints. In most cases, we can totally avoid data redistribution by identically segmenting projections based on join keys or replicating the dimension tables. Depot pinning policies. In Eon mode databases, entire data resides in communal storage and recently accessed data in the depot. Reading data file from depot is faster compared to reading the same data file from communal storage. Due to this, a given query performance may vary depending on if all the query process data read from depot or from communal, or part of the data from the depot and other part from the communal. One can configure depot size such that most of their present working data set resides in depot. If required, one can modify the depot size using meta functions like alter location size, which lets you to change depot size on one node or all nodes in a given subcluster, or all nodes in the database. Even with all care taken to properly size the depot, there is possibility Vertica evicts data from depot as needed to provide room for the new data. So in this case, Vertica provides an option called pinning database objects, which helps in preventing data file eviction from the depot. We can set pinning policy on a table or a projection or a partition by using the different functions or different options given here. Configuration parameter prefetch pinned object to depot at startup can be enabled to fetch pinned objects during the node startup. With this, I'm done with my part of this presentation. Hibiki will continue the remaining part. Over to you, Hibiki.
Thank you, Rakesh. Hello, everyone. My name is Hibiki Serizawa. Today, I will cover 5 performance-related use cases which we have addressed recently in our customers database and which applying our best practice shared by Rakesh. Let's start by looking at the first use case. This case is related to the resource request queue. The database usually works fine, but sometimes query response becomes to be slow, especially when the database is very busy. In such case, check the number of running queries on each resource pool, system resource usage, and resource usage on each resource pool. In this use case, we saw a little high system resource usage, but it had enough room. Then we check the query concurrency on a certain resource pool using DC resource pool status table. Look at the graph on the left. This graph shows the max number of running queries by hour. 90 queries are running at the same time, between 10 and 11. The database should be very busy. This time slot matches the time the customer saw the query response was slow. Look at the graph on the right. This graph shows the max memory usage by hour. Blue line is the max memory size of resource pool. Orange line is the threshold of the memory size in use. If the memory usage by running queries exceeds this threshold, the resource request by new incoming queries and running queries is placed in the queue. Red line shows the max memory usage by hour. Between 10 and 11, it exceeds the threshold, so the queries require additional memory need to wait, and this makes the user's field query response is slow. If the waiting time exceeds queue timeout parameter of resource pool, the query is cancelled with the message resource reservation failure in Vertica.log. There is another resource reservation failure message with request for resource was cancelled. This message indicates that the query is cancelled before allocating the resource. In case of resource request queue issue, we can consider several options. The first option is to increase max memory size parameter of resource pool so that more queries can run concurrently and the query can allocate more memory. But it may require additional physical memory, so it is not easy for some of you. Next option is to increase planned concurrency parameter of resource pool so that the query budget becomes smaller and more queries may be able to run concurrently. On the other hand, it may harm query performance. So please be careful if you take this option. The third option is setting the limitation for the queries which are using many resources or running for a long time. Max query memory size parameter can set the max memory usage of each query. And the runtime cap parameter can set the max running time of each query. It may affect the negative impact on the high resource allocation query and long-running query. However, it has a chance to improve the other query performance. The last option is tuning the queries to use the operations which use less memory, like using group by pipeline instead of group by hash, or using group join merge instead of join hash. Let's move on to the next use case, which is related to the statistics. The problem the customer hit is query response becomes to be slow after collecting stats. In such case, check the stats is collected without any issue and find the differences between the two query plans before and after collecting stats. Firstly, we check the status of stats. In this case, analyze statistics runs every 6 hours every day without any issue. Let's look at the query plan before collecting stats. As you can see, the query plan shows no statistics when accessing table 1. But we cannot see any other issue. This is true because the customer did not see any slowness. Next query plan is the one after collecting stats. The query plan shows predicate value out of range when accessing table 1 with a filter using rel timestamp time column. And the row count of table 1 is only 2. So the optimizer picks this table on inner side of the join operation. The real row count is 1 billion. Join hash needs to build hash table for 1 billion rows. It takes much time. So the query response becomes to be slow. Please remember the timestamp used in the filter. 25th May, 3 p.m. and 4 p.m. Why does it happen? This is the status of stats on the rel timestamp type column, which is used in the filter. The type of stats for this column is full, which means the stats has been collected by analyzed statistics. So, why the query plan shows predicate value out of range? Let's look at the histogram data. You can export the stats using export statistics function. The data on the left is collected by analyzed statistics using 10% sampling data. The data on the right is collected using 100% data. As you can see, the mean value of this column is the same, but the max value is different. The data type of this column is timestamp with time zone. Let's convert the mean value and max value. The mean value is 25th May, 8:25 a.m. The max value when using 10% sampling data is 2:40 p.m. And the value when using 100% data is 5:15 p.m. Do you remember the timestamp used in the filter? Yes, it is 25th May, 3 p.m. and 4 p.m. This timestamp is out of range if the histogram data is collected using 10% sampling data. This is the reason why the optimizer makes the non-ideal query plan. The percentage of sampling data affects the collection time and accuracy. 10% is the default value of analyze statistics function. The smaller percentage is faster, but it might compromise histogram accuracy. On the other hand, the larger percentage takes a long time, but it enables greater histogram accuracy. In case of this issue, the solution is collecting stats with larger percent sampling data like 100%. But it takes a long time if the table has huge data, so it may not be acceptable. If it is not acceptable, consider collecting the stats only on the predicate columns. Move on to the third use case, which is related to the data redistribution. The problem is query response was slow after expanding nodes from single node to 3 nodes. In such case, check the query plan and execution engine profile on 3-node database. If you expand the nodes on your database, it decreases the data volume processed by one node. It improves the query performance, but it needs the network-related operations to communicate between the nodes. It may affect the query performance. Let's look at the query plan. As you can see, the query plan shows global resegment groups on group by hash operation. It has fetched data from the other node to aggregate the data. Check the execution engine profile to know the longest operation. In this case, group by hash is the longest operation. You will see the operations like group by pipe, network receive, network send do not appear in the query plan. You can see these operations in the query plan graph on the right. The solution is to create an identically segmented projection. If it segments the data by the group by columns, it can avoid the data redistribution. Moreover, it can improve the query performance if it sorts the data by the group by columns to use group by pipeline instead of group by hash. Let's move on to the next use case, which is related to query hints. The problem is the query response is slow regardless of collecting stats. In such case, check the query plan and stats. In this case, analyze statistics runs every night. When we review the query plan, it was a non-identical query plan. Unfortunately, the optimizer makes the non-ideal query plan if the query is very complex. You can see the optimizer picks the larger table on inner side of join operation. To solve this issue, we have the option to use query hint. To add syntactic join hint, the optimizer enforces the query's join order exactly as specified. Vertica has some query hints to assist the optimizer. For details, please see the product documentation. Label hint does not have any impact, but it is very useful when profiling the query. We have group by type join type, union all type hints, which make the optimizer enforce the operation type. Move on to the last use case, which is related to the pinning table object on ear mode. The problem is query performance is not consistent, sometimes fast and sometimes very slow. In such case, check the query plan, the resource pool usage status, and the data volume when the query runs. This database is ear mode, so we need to check the storage location where the query fetches the data from. In this case, the query used the same query plan. We did not see any resource contention and no difference in the data volume. But we saw, in case of slow query, the query was fetching data from communal storage. To make the query fetch the data from table, pin the table, projection, or partition. This is a solution to this issue. In this session, we discussed major query performance issues, our best practices, and the customer use cases. I hope that our presentation today will help you to solve the performance-related issues. Thank you for listening to our session. Now we are ready to Q&A.
Great presentation, Rakesh and Vicky. We've had some good questions come in. So you jump right in and see which questions got the most votes, and we'll start there. All right. It's like the top vote getter was, when most of my users report that queries are running longer than expected time, what can I quickly check to find the source of the issue?
Yeah.
Rakesh or Vicky, I don't know if you want to lead.
Yeah, I will take it. So first I will try to see, I will try to check if while the users are reporting that their queries are running slow, I will try to check if the workload is similar, or what you the number of queries running on the database is what you are expecting, or is that in line with your expectation. That means, is the load on the database is more or on the lines what you are expecting. So say for example, are you running an ETL job is supposed to be running at that time, is only ETL job is running, or a couple of other jobs are running. So first I would try to see if the present workload is the cause for it. If your number of concurrent queries are running similar to as per your expectation, then I would see, is there any long running or complex query, or a analytic type of query which is consuming a lot of resources or causing the problem. So first I would then I would go to see, is there any slow running query, then identify those transactions and query a couple of DC tables to see how much memory it is using, those kind of things. So once you figure out the workload side, if you don't find anything on the workload side, then I would go and check on any resource related contentions are happening. So for that, maybe you can see, is all your queries as soon as users are issuing starting execution, or the queries are waiting in the resource queues for the memory. So I would see if there is any memory related contentions are going on which resource pool the queries are coming in, are they immediately going to running state or just waiting in the resource queues. Also I would check if there is any lock side lock related contentions are happening. So for this we may have to query certain DC tables, like the system tables, locks, lock requests, lock waits, those kind of things. So once we check these two, then also I would query the system resources table to see if there is any CPU related issues are going on, or any disk related. So for this you can run it, any tool you can use it Linux side, you can run it individually on each node, or maybe you can query Vertica provided system tables to identify if there is any one particular node the resources are very high or something like that. Also you can even try to see if there is any system side issues are going on, like maybe a disk related issue is happening on one particular node, or IO is bad on one particular node, or maybe network side drops are happening on any particular node. So that can also cause, like one bad node could also impact on overall database slowness or impact on every user queries. For this, maybe you can use like simple test like a KV hint to identify if there is any slow performing node in the database. So if you can narrow it down to that slow performing node, then you can query to see if there is a high load average is there, or maybe any disk or network issues are going on with that particular node by reviewing the D messages or varlog messages. And also you can use a Linux tool called perf tool, perf top you can run to understand which kind of functions, either it is a Vertica related or it can be a system related function where the system is spending a lot of time. So that will also help you to narrow down what might be going on with that bad node. So these are few tips which could help you to narrow down what could be causing the slowness.
Great tips, Rakesh. So I know the attendees in the audience realize that you deal with some really Vertica experts here with based on years and years of knowledge working with customers. So great, thorough response there. Let's go to the next one. When reviewing the query plan, which part should we focus on first? Who wants to take that one?
Yeah, I will take it. So please check if the query plan indicates no statistics or the predicate out of range first. If you can see one of them, please correct the statistics and get query plan again. So next important point is the two tables on the join operator are placed on the right side, inner side or outer side. It should be better to place the larger table on inner side. The third important point is a data redistribution and the operation type of join and group by. So it's better to avoid the data redistribution. So join merge may be better than join hash, and group by pipeline may be better than the group by hash. But it depends on the execution time. If execution time of each operator is very short, you don't need to change it. You cannot know the execution time from the query plan, so please check the execution engine profile as well. Yeah, back to you, Jeff.
Hibiki, thanks so much. Great. Okay. Well, we got a ton of questions coming, and we want to remind the audience that Hibiki and Rakesh will answer them offline. So don't worry about if they're not addressed. We're going by the top vote getters here. And the next one is, in case of cascading resource pool, when query moves from primary to second pool, does query restarts its execution? And then there's a follow-up question here. Hopefully you guys can see it. Query budget on second resource pool have any impact on the query plan or execution time? Who wants to tackle this one?
I will take it. So when by default, when a query moves from primary to secondary, it just continues. It doesn't restart. It continues its execution using a similar plan, same plan and same resources. This is by default. But there is an option you could control. There is a configuration parameter which a user can set it to replan on moving to the secondary pool. So in that case, whatever the part of the execution it did on the primary pool, completely it will be thrown out and the query will be restarted from the scratch. So this is useful when you are moving a query from a very tight budget or a very short queries pool to a secondary pool where you have more resources, where you would like to run a query with a higher budget so that a better parallelism can be utilized. So in those cases, maybe you can consider setting this configuration parameter so that your query could be restarted, replanned, and restart with a better plan, with better parallelism, and would work execute faster.
Very good. Okay. Thanks again, Rakesh. Okay, next one here, next top vote getter. Do we need to update statistics after every DML, or how frequently do we need to update stats on table?
Yeah, I will take it. So in general, we don't have to update statistics on every DML. So by default, initially when you load the data, you have to update the statistics, and after that, only when there is a huge change of the data, like maybe 30% or 50% of the data change, that times you need to update. And another thing you could make use of it is in the recent releases, Vertica is providing partition-based statistics. Suppose say you have a fact table with multiple days worth of data or multiple months worth of data. You don't have to update the statistics on the entire table. You can update the statistics only on the partitions on which you plan to query or you are loading the new data. So you can make use of those partition-based statistics based on your query load and based on your load requirements. So yeah, in general, you don't have to update the statistics on every DML.
Got it. Don't have to update stats. Okay, that's helpful. We've got a question around the use cases. Hibiki, I think you covered these, right? One was in use case number 2, there was an example to convert the numeric value to the timestamp in the histogram data. How can we convert it?
Yeah, I'll take it. So conversion method is not described in the product documentation. So I posted this method in the Vertica user forum before starting this session. So please search by this session title, Tuning Vertica for Performance at Scale. So if you have any other questions regarding the histogram data, please let us know anytime in the forum.
Very good. Thank you, Hibiki. And we've got another one around histogram, another vote getter here. We use analyze underscore histogram on predicate columns with 2% as row counts in trillions instead of analyze underscore statistics. Is that okay?
Yeah, I think that is okay. So analyze histogram will allow you to use a percentage as one of its parameter, whereas analyze statistics by default analyzes the 10% of the data. So you can use a percentage in the analyze histogram to do more analysis up to 80-90%, or you can do it on a lesser percentage of data. As I said in my answer to the previous question, you can even, if you have a table with the trillions, billions of data, you can even, if the table is a partition, consider running the analyze statistics, partition-based statistics.
Very good. Thanks, Rakesh. I think we have time for one more. And okay, let's go with this one. We have JType Hint to make the optimizer in join type. What is the difference between using JType Hint or using the subquery for the pre-sort?
Yeah, I'll take it. So using JType Hint is easier than changing the query to use a join merge. But JType Hint has some restrictions that the join condition must be simple and the join column must be the same data type, precision, or scale. So in addition, as JType Hint requires the syntactic join hint, so you have to apply the other restrictions by the syntactic join hint as well. So in many cases, you need to try to change the query to use a join merge instead of using JType Hint.
Thank you, Hibiki. And great job with the questions. We're going to wrap it up now. That's all the time we have. Thank you, our audience, for your great participation. If we weren't able to answer your questions today, we'll do our best to respond directly via email. And again, our engineers will be in the developer lounge as well. Make sure you hit the developer lounge. Please note that a replay of today's event and a PDF copy of the slides will be available on demand shortly. And of course, we invite you to share them with your colleagues. Again, thank you to our audience today. Don't forget to type the session code into the Analyze to Win section on the event navigation panel. Note that there'll be a short message from our sponsor that I'd encourage you to stick around and catch. Now, this concludes this breakout session. Have a great day, and we hope you enjoy Vertica Unify 21.
Stand set off of turn number 4.